In this example, we have the vector space C minus pi to pi. So this is a vector space of all function, continuous function with the domains minus pi, with the inner product given by the formula 1 over pi integral from minus pi to pi f of x g of x dx. We need to show that the set with functions 1 over root 2 cosine of x, cosine 2x, cosine 3x, cosine n of x, cosine n times x form an orthonormal set. And then we need to compute the integral from minus pi to pi of sine of x to the power 4 dx. So for the first one, we need to show this is an orthonormal set. This is orthogonal set. And each vector is unit vector. So they are pairwise orthogonal. So that's the first step, and then we compute the norm to show the second one is each vectors or each function is a unit vector. So this means that we need to show 1 over root 2 is orthogonal to cosine of kx from k is from 1 to n. Second one, we need to show that cosine of, say, mx is orthogonal to cosine of kx for m different from k and still in the set from 1 to n. Okay, and to do so, we just need to compute the inner products, and if the inner products of the two functions is 0, then the two functions are orthogonal. So we compute the inner products of 1 over root 2 cosine of kx. We want to show this one is 0, and we also want to show that the inner product of cosine of mx with inner product cosine of kx is also 0. So mk is so we use the same notation. Mk is just number from 1 to n, m different from k. Okay, for the first equality, let's compute the integral. So the inner product of these two functions is the integral. So by definition, is the inner product is given by this formula. So this is 1 over pi integral from minus pi to pi f of x, so 1 over root 2 g of x cosine kx dx. So this is 1 over root 2 times pi minus pi to pi cosine kx dx. And this integral will be 0. Calculus 1. Okay. For the second one, we compute this second equality. We do the same computation. This is by definition 1 over pi from minus pi to pi cosine mx cosine kx dx. And here remember that m is different from k. And say 0, you compute yourself, say calculus 1. And with that, we show the two functions are orthogonal, and the two functions are orthogonal, and therefore they are the set. We are given this set. They are pairwise orthogonal. Now we need to compute the norm of each function to see that the norm is indeed 1. Step 2, we need to show that norm of 1 over root 2 is 1, and norm of cosine of kx is also 1 for k from 1 to n. Okay, I should say something about this function. 1 over root 2, we think about it as the function from minus pi to pi go to r, right? The function is a continuous function, and this function takes any points x there to 1 over root 2. Actually 1 over root 2x, and this function is return 1 over root 2 for any x from minus pi to pi. Yeah, so the constant function. And computing the norm is given by, recall that the norm of, say, u, vector u, will be square root of u's inner product with itself. So the inner norm of 1 over root 2 by definition is square root of the inner product of 1 over root 2 with itself. And by definition of the inner product we have, this is 1 over pi minus pi to pi 1 over root 2x, right, equals 1 over root 2 times 1 over root 2 dx. So this gives us 1 over 2 pi this is 1. So the first vector is a unit vector, and the rest cosine 1x, cosine 2x, cosine 3x. So normal cosines of kx, square root of inner products of cosine of kx, cosines of kx. And this is by definition, our definition of inner product is the integral kx square dx. And yes, again, calculus 1 questions, so you compute yourself, this is 1. So this is true for all k's from 1 to n. So each vector in the set is a unit vector. The set contains on the function 1 over root 2 cosine x, cosine 2x, cosine nx is orthonormal set. Okay. The second question we need to do is we need to compute the integral of sine of power 4 of x dx. And we will compute it with the inner product using inner products. So this first recall that. So we will use trigonometry, so sine square of x can be written as 1 minus cosine 2x over 2. Yeah. So recall we have this. So it just means that's 1 over 2, right? Cosine 2x over 2. We want to write in terms of linear combination of the orthonormal basis we have. So 1 over root 2, 1 over root 2, 1 over 2 cosine of 2x. Here are two vectors in the orthonormal set, right? And here are coefficients, so it's scalar in our case. So we can use the Parseval theorem. So recall the Parseval theorem we have. So if we have orthonormal set U1 to UN, if we have this is orthonormal set in a vector space, inner product vector space. And we have a vector v, say v is written as linear combination of these n vectors, so ci ui. Then Parseval theorem say that we can compute the norm of vector v, and norm vector v square is the sum of all the coefficients square. So on to n. We will apply the Parseval formula for our case. So we express vi, say, so in this case we express sine x square in terms of linear combination of two vectors in the orthonormal set that we just proved in the first part, right? 1 over root 2 and cosine orthonormal. So now we have the integral we are given is minus pi 2 pi sine power 4 x dx. This is the same as, so pi, and then we have the inner product. Our inner product is 1 over pi from minus pi to pi, right? And we have sine square of x, sine square of x dx, right? So we have sine over 4, we have sine square and sine square. And this one is by definition the inner product of sine square of x with itself, right? Pi times the inner product sine square of x. Yeah, that's definition of the inner product. Our inner products. And this means this is a norm of sine square of x square, right? By definition, norm of v square is the inner product of v with itself. In our case, v is the function sine square of x. Okay, and by Parseval formula, norm of v square is just coefficient square and we take the sum. So pi is still there, and this is, we have the linear combination we computed before. This is a linear combination. So here is our coefficient by Parseval formula. This gives us pi 1 over root 2 square plus minus 1 over 2 square. So this gives us 1 over 2 plus 1 over 4. So 3 pi over 4. So here's a way we use Parseval formula to compute the integral of this function.